Imagine you are standing outside at night, looking up at the stars. The sky looks peaceful, quiet, safe. You have looked at this sky your entire life, and it has never once threatened you. But there is something up there that you cannot see, something that does not glow, something that does not announce itself, something that bends the light around it so completely that it leaves nothing, not even the hint of its own existence, for your eyes to find. And it is closer than you think. Most people imagine black holes as distant things, objects at the edge of the universe, problems for another galaxy, another civilization, another time. The kind of thing that exists in science fiction and theoretical physics papers and nowhere near the neighborhood where you live. That is not accurate. The closest known black hole to Earth is called Gaia BH1. It sits approximately 1,560 light-years away. That sounds far. And in human terms, in any terms we have language for, it is. But in galactic terms, in the scale of the Milky Way, which is 100,000 light-years across, 1,560 light-years is nothing. It is next door. It is the house at the end of your street. And here is where everything changes. Because Gaia BH1 is the closest one we know about. The operative word is no. Black holes are invisible, not metaphorically invisible, physically, literally, completely invisible. They emit no light. They produce no radiation that our telescopes can easily detect. They announce themselves only through their effects, through the way they bend light around them, through the way nearby stars move in response to their gravity, through the way gas and dust falling into them occasionally flares up in a burst of X-rays before disappearing forever. We find black holes by looking for the things they do to the space around them, not by seeing the black holes themselves. And here is the problem. Most black holes are not actively consuming anything. Most black holes are sitting quietly in the dark, not pulling in gas, not bending enough nearby light to be detectable, not doing anything that would make our telescopes notice them. They are simply there, massive, invisible, patient. The Milky Way is estimated to contain anywhere from 10 million to 1 billion stellar mass black holes. We have confirmed the existence of a few dozen, which means the vast majority, tens of millions, possibly hundreds of millions, are out there right now, undetected, unnamed, unknown. One of them could be closer than Gaia BH1. We would not necessarily know. But here's the real problem. Let's talk about what a black hole actually is. A black hole is not a hole. It is not empty space. It is the opposite of empty. It is matter compressed to such extreme density that the mathematics of space and time break down around it. At the center of a black hole is a singularity, a point of infinite density, where our physical laws stop working, where the equations that describe the universe produce answers that are not answers but failures. Division by zero. Infinity where infinity should not exist. Around the singularity is the event horizon, the point of no return, the boundary beyond which nothing, not matter, not light, not information, can escape. Not because something is holding it back, but because beyond the event horizon, every path through space and time leads inward. There is no direction that points out. Outward ceases to be a direction. The only way is down. If you cross the event horizon of a large black hole, you would not feel it. There would be no wall, no alarm, no physical sensation of crossing a boundary. You would simply be inside. And from inside, you could look outward and see the universe. But the universe could never see you again. You would be gone from it completely. Present, alive, unreachable. But it gets worse. If you fell into a stellar mass black hole, the kind that forms when a massive star collapses, you would not survive the approach. Long before you reach the event horizon, the difference in gravitational pull between your head and your feet would become so extreme that you would be stretched. Scientists call this spaghettification. It is one of the few times in physics where the technical term is also the most viscerally accurate description of what would actually happen to your body. You would be pulled into a strand, thinner and thinner. Atom by atom, the tidal forces would extend you in the direction of the black hole and compress you from the sides. You would become a stream of particles, accelerating towards something you cannot see in a process that is complete and irreversible and takes only seconds. But here is where it gets truly frightening. From your perspective, time would slow down as you approached. From the perspective of someone watching you fall, if they could watch, if they were safe at a distance, you would appear to slow down, to freeze, to hang there at the edge of the event horizon for what would appear to be eternity. You would never appear to cross it. The light from your image, stretched and reddened by the extreme gravity, would persist at the edge forever. Two perspectives, both real, both true. The universe bending its own rules to produce two simultaneous and contradictory realities from the same event. And here is where everything changes again, because stellar mass black holes are not the most frightening kind. At the center of the Milky Way, approximately 26,000 light-years from Earth, there is a supermassive black hole called Sagittarius A star. Its mass is 4 million times the mass of our Sun. 4 million. The Sun is 330,000 times more massive than Earth. Sagittarius A star is 4 million times more massive than that. If you replaced our Sun with Sagittarius A star, its event horizon would extend past the orbit of Mercury. The innermost planet of our solar system would be inside it. The image of Sagittarius A star was captured for the first time in 2022 by the Event Horizon Telescope, a network of radio telescopes spanning the entire Earth, working together as a single instrument. The image showed a glowing ring of superheated gas around a dark center. The dark center is the shadow of the event horizon, the first direct visual evidence that the thing at the center of our galaxy is real. We live in a galaxy with a 4 million solar mass black hole at its center. We always have. It has always been there. And for most of human history, we had no idea. But that's still not the worst part. Black holes grow. They consume. Gas and dust that drifts too close gets captured, pulled into an accretion disk, a swirling ring of superheated material orbiting the black hole at a significant fraction of the speed of light. The material in the accretion disk reaches temperatures of millions of degrees. It radiates X-rays. It glows, and then it crosses the event horizon and is gone. When a black hole is actively feeding, it becomes one of the brightest objects in the universe. A quasar, blazing with the energy of trillions of suns, visible from billions of light-years away. The most luminous objects ever observed are black holes eating. Sagittarius, a star, is currently quiet, currently not feeding, currently sitting at the center of our galaxy in a state of relative calm. But in approximately 4 billion years, the Milky Way will collide with the Andromeda galaxy. Two galaxies merging, hundreds of billions of stars rearranging themselves over millions of years. And when they merge, the two supermassive black holes at their respective centers will spiral toward each other. They will orbit. They will merge. And the resulting black hole, combined mass of both, will begin feeding on the chaos of the galactic collision around it. The Milky Way's black hole will wake up. There is one more thing, something that sits with you after you learn it. Everything that has ever fallen into a black hole is still there. In some sense, compressed beyond recognition, beyond atoms, beyond any structure, but there. The information of what it was, its mass, its quantum state, its existence, is not destroyed. At least we think it is not destroyed, This is called the black hole information paradox, and it is one of the most unresolved questions in all of physics. Stephen Hawking spent decades working on it. He proposed that black holes slowly emit radiation, what is now called Hawking radiation, and that over an astronomically long period of time, black holes evaporate. They lose mass slowly, imperceptibly, across timescales so vast they make the current age of the universe look like a brief introduction. A black hole the mass of our sun would take 10 to the power of 74 years to evaporate. The current age of the universe is approximately 14 billion years, 10 to the power of 10. The difference between these numbers is not a matter of scale. It is a matter of category. Black holes will be the last things in the universe, when all the stars have burned out, when all the galaxies have gone dark, when the universe has expanded to a cold and empty stillness. Black holes will still be there, slowly evaporating, releasing the last energy of the universe in faint whispers of Hawking radiation, until they too are gone, and the universe will be silent. Here is what stays with you. Right now, at this moment, there are tens of millions of black holes in our galaxy alone, most of them invisible, most of them undetected, most of them sitting quietly in the dark, doing nothing, waiting for something to drift close enough. You have looked up at the night sky your entire life. You have seen stars and planets and the faint band of the Milky Way. You have felt the sky was something you understood, named, mapped, measured. But the sky you see is not the sky that exists. The sky that exists is mostly darkness, mostly invisible, mostly things that announce themselves only through what they do to the space around them. And somewhere in that darkness, closer than you think, unnamed and unknown, something is waiting. It does not need to find you. It just needs you to drift close enough. And gravity is very, very patient.